All right, welcome everybody to the final day of QuickPass. If you've stuck around and whether you're watching this live or on the YouTube recording, I'm glad you're here to follow along. This week we have been really just using what we've learned over the course, the first 2 weeks of the course, where we learned new material and applied it to different projects. The first day this week, which was on Tuesday, we went over like a paragraph and we extracted the sentences out and counted the words, counted for edge cases, kind of did a little bit of that computational thinking. And then we dove into a phone number scrubbing exercise where we were taking a dictionary, a Python dictionary, and processing it, cleaning up, getting rid of the foreign numbers and, cleaning up the US numbers in that data set. And then yesterday we went over the lottery, multi-state lottery. We simulated the process of generating a ticket and getting a drawing and then comparing and seeing what we could win. And then we went so far as looping over it 500,000 times and to see how much we could win if we had $1 million to spend on the lottery. So I thought it was a good exercise. Hopefully y'all learned something. And today we're going to do much the same. This would be the final exercise. And this one's a pretty good one too. We're going to take a real world problem, and it's not really a problem, but we want to make something with Python that represents something in the real world, and we have to think about the problem itself, breaking down the sub problems, looking at the constraints of the data set. How are we going to establish that? What are we going to be dealing with? How are we going to process it? And so it'll be a fun exercise. I'm going to start sharing my screen and we can kind of see what we're looking at here. So I can get everybody up to speed. Let me see here. Share window so I can see the questions as they come in. And if we have the attendance link, that'd be good. Okay. All right. So here we're dealing with really mini projects, 3 or 4 now. We've done quite a few, but this is originally mini project 2, and we're gonna take a look at another problem with Python, something that's probably take the entire evening, and we're gonna use Python to build a poker hand evaluator. And so for any of y'all who hasn't played poker before, it's a really easy game to learn. This is kind of one of those idioms, but poker is a very easy game to learn but hard to master. And it's, for me, it's really the only casino game I'll play because you're not playing the house, you're playing other people. And so as long as you study up and you learn the game and the nuances, you can beat other people, and you can take money from them while losing as little money as possible to other people. Sometimes it doesn't always work that way, but in the long term you can become a winning poker player if you play correctly. And there's a whole bunch of nuances. As a poker player, I'm not going to get into all of those, but in the overall general sense, it's a game with 2 or more people, and then of course the maximum player count is determined by the type of the game, and the cards can be dealt all sorts of ways, but the very basic form is you have a 5-card hand, and you're trying to win the chips in the middle. The chips typically stand for real money in cash games, but it can also be a tournament where you buy in, then you're as long as you have chips, you're still alive in the tournament. So, but there are other factors that go beyond the scope of this. We're just looking at straight poker hand evaluator, but I mean you can actually turn a night where you're getting really cruddy cards internet where you're winning if you happen to be bluffing at the right time and representing a better hand than you have, and so you could actually make money with terrible hands. Um, and so that's where the skill comes in. And a little more background about the game. I have a graphic in here, and I think when I adjusted it for the course, it really became super like granular, and you can't really read it and small. So I pulled up another one here on this site showing the ranking of hands. And this is important because we're going to be building an algorithm that evaluates cards and then tells us what hands we have. And we can go even further if we have time, where we can maybe take two hands, evaluate them against each other, and see which one is the better hand. I doubt we'll get there tonight, but that could be something that you can do on your own time with the code base, for an exercise on your own. Because it's always good to build these little mini projects to kind of, test out your knowledge of Python. But back to the hands here. The lowest hand you could have is a high card, so you don't have a pair. And it's just whatever the highest card in your hand. That's the best. That's the best hand you have. You just the highest card. You can win hands with a high card. Sometimes two or more people will have just high cards, and whoever has the ace wins. Usually. Moving up, you have a pair, so that's you have just a pair of matching cards as far as the rank of the card, not the suit. Of course, if it's the same rank, you have different suits, but a pair is just a single pair, and they're also ranked in order. So a pair of aces beats a pair of kings, so on and so forth. Two pair, just two pairs with an extra card. A three of a kind has three of the same card. And then the next one, so each one of these progressively beat the other ones below it. So a straight will beat a three of a kind always. A straight is any cards in order, but they're different suits. So you have a mix of red and black cards. And one thing to note here, and just kind of keep in mind, is that the ace, which is typically high, can also be low in a straight. So an ace can stand for a 1. So 1, 2, 3, 4, 5. Or an ace can stand for the high card, and you can have 10, jack, queen, king, ace. So that's one thing to keep in mind. The next hand is a flush. And so the flush is non-sequential cards, but they all the same suit. So if you used all diamonds here in this example, so that would be a flush. If two flushes are going against each other, the flush with the highest card or highest next best card, so on down the line, would be the winner of the hand. Higher than a flush is a full house, which is a mash between a three of a kind and one pair in the same hand. So you have three aces and two sevens in this example. And then next highest hand is a four of a kind. There are only 4 cards of any rank in a deck, so it is pretty rare to get all 4 of those cards in one 5-card hand. It is pretty rare. The next two are basically the same hand, just the cards on, as far as the ranking of the cards go. But a straight flush is a straight, also with the same suit. So 6, 7, 8, 9, 10 here, all diamonds. And then a royal flush is just the highest straight flush you can have, and it's the best possible hand in Texas Hold'em. And in all the years I've played, outside of like silly game poker, I never in a live hand, like for money, have I ever gotten a royal flush. I've gotten a straight flush before, but I've never gotten a royal flush. So they're pretty rare. But those are the poker card hand rankings, and we're going to use Python to evaluate the hand and figure out what we have. And so that's going to be one of our objectives there. And so that's just kind of a background on poker, the hand rankings. And with that information, I think we're armed, with all we need to start, converting that to Python and getting some code down. So if we think back, okay, so we want to evaluate a 5-card hand, and we want to then have Python tell us what hand we have. That's the goal. If we go back and we look at, okay, if we have our problem-solving strategies in computational thinking, how can we break this problem down? What do we need to get going. And then we can again start with pseudocode, so we can kind of make comments and just write down what do we think we need to even start to evaluate a hand. Does anybody have any suggestions? Okay, so we got some here. We got define the hand rankings. Okay, yep, we probably need to define the hand rankings somehow. A dictionary of card values. Okay, we can do a dictionary. So here, like, define hand rankings. Okay, and a dictionary, maybe a dictionary, or a dictionary and or other data set to hold card values. And I think where you're going with this is like, maybe like, I mean, do we need a deck of cards?
Yes, we'll need a deck of cards.
Oh, yep. So
Aaron.
we'll need a deck of cards.
A full deck, sir.
A what?
A full deck.
A full deck of cards. Yep. Okay. So we need a full deck of cards. All right. Okay. Yep. Enum. We're not learning about enums in this course, but yep, we could use that.
Are we doing Texas Hold'em?
No, we're just doing poker. So it's just we're gonna get a 5-card hand, because in Texas Hold'em you can get a 5-card hand. It's just you have community cards. But in this case, we're just getting a hand of 5 cards, and then we're gonna have Python evaluate it and tell us what hand we have. That's really it. Okay, so yeah, I think the most important part is probably getting a deck of cards. I think that's probably the most important thing, because if we don't have a deck of cards, we don't have poker hands. We can't really get started without that. So I think that's probably the most important thing we can do. And so using the tools we've learned in this course, like, I guess we have other questions like, okay, well, what would the data structure look like for a deck of cards? What would, how would we even create one out of thin air? And so maybe we can tab this over and say, okay, well, how do we create one? A class? I mean, we could. We're not learning about classes here, and I don't think we have to go into object-oriented programming for that. Yeah, we don't have to go into in-depth there. I think we can do it without that, just to kind of stick with the basic data types of the course. But what other data structure perhaps could we use to make a deck of cards? How many cards are in a deck of cards? Oh, Miguel just put it all out there, right? So he goes, deck 52 cards, 2 through 10, Jack, Queen, King, Ace of hearts, diamonds, spades, and clubs, making a dictionary with the key being the type of card and the value being the value. So like okay, so the key being the type of card, what do you mean by that?
Cards like the hearts, diamonds, spades, and club.
So the key would be, they'd have to be unique keys.
Oh no, okay, never mind. I see it. see what happens.
Okay. So 52 cards in the deck, a dictionary of arrays. What about just a list?
List or a set.
Yeah, a list or a set.
And then each value can be a string. So like King of Hearts could be KH. So your second letter is always your suit, and your
Hmm.
first letter in the string is always your value.
Okay. Yep. That sounds pretty good. I kind of like that idea. So maybe like, okay, so create a list of cards, and they are strings. And let's go ahead and get like an example of how they look, right? So so it kind of look like this, right? So we have this, and we can do like maybe King of Hearts, and then like 6 of clubs, three of diamonds, ace of spades, and let's do king of diamonds. Okay. And so maybe this would be like a hand, right? But then we also have a list of all of the cards, and then we can maybe pull a card or any cards we need out of that big list of cards. So maybe something like that. Or if we don't want to change them, we can make it like a tuple or something, right? I also like the idea of a set of cards for the deck. That way you kind of guarantee uniqueness. But I think we can guarantee uniqueness because we still have to create the deck of cards, right? So this would be like a hand here. And then so how could we create a deck of cards that's going to be a list? So like let's say for example we have deck of cards and it's an empty list. How do I fill this empty list with cards? Ooh, Jason says 2 loops. What will we loop over? Ah, okay. Okay, so the first loop hits 2 through ace, and then the second loop covers the card type. Okay. Or you can do it either way, really. You just want to loop over one while you're getting the other. Okay. So we could do something like this. Like we have suits equals, and I can make this a list, and I can say diamonds, hearts, spades, and clubs, right? And then I can do like values equals. We can do ace, 2. This is probably the most we're gonna type. Imagine doing this 52 times, right? And doing okay, ace of diamonds, 2 of diamonds, 3 of diamonds, doing all these little strings. That would be it'd be brutal. 5. Okay. Maybe you could ask ChatGPT to make this list for me. Okay. So 52 cards, we have 13 values for suits. Put it together, we should have 52. Okay. Okay. And do we think it's probably best to keep it strings?
Hey, Aaron, I've got one question here.
Yeah.
Just trying to think ahead because we're going to be comparing the values, like which one is greater to see like what hand might win over another hand.
Mhm.
Would it be
We-
better to do, instead of do like A, J, Q, K, would it be better just to go 1 through 13? Because then you could actually compare the numbers, like which is greater, which is less.
We could, but remember, ace is also, ace is really one or, ace can be low or high.
Yeah.
So, if we get to that point, we can maybe look at considering like the value of a card actually being equated to a number. I don't know if we're going to get there tonight, but if we do, we can go over that. And I think, probably a good data structure of that would then be a dictionary at that point, because we can set like a key value. So,
Oh, yeah.
but yeah, I think, right now we're just looking at one hand, and we'll see if we can just, find whether we have a full house or a straight, right? But, we'll see if we get there. We may, because, if we work pretty quickly, we can get there. But I just want to make sure that, we're getting suggestions from everybody, because that's the best part, like, of learning is, contributing and seeing the results of your ideas. So yeah, we can, Jason hit the nail on the head with this loop here. He's saying for value and going over the values and then going over the suits. You can do it either way. You can go over suits first, then values. It really doesn't matter. And so we could say, we have our empty deck of cards already, so we can just say for, we can say for value in values, and then do for suit in suits. And so I'm doing, this is kind of weird because we are kind of going over a matrix, but not really, because we're not looping over like anything nested. We're just looping over two separate lists, but we want to loop over one of them while only hitting one item in the outer loop. So in this case, we're going to hit the A, and we're going to hit the D, H, S, C while A is still highlighted by value. And then, so this loop will run to completion over suits before this next one increments up one. And so then value is going to hit 2, and we're going to hit diamond, heart, spade, club. And then we're going to go up 1 to the 3, diamond, heart, spade, club, 4, diamond, hearts, like so on and so forth, right? So all we have to do then is say deck of cards dot append, and then we can do an F string just like he has there, and we can inject the value, and then we can inject the suit. And then we can just take a look and see if we get a nice deck of cards here. Let me select my kernel. Sure looks like it. Ace of diamond, ace of hearts, ace of spades, ace of clubs, boom, 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 all the way down. So we can also check the length, which we should see 52, but we can always just check to make sure. And we have 52 cards. So we don't have to have a set if we do it this way, because we know we're guaranteeing uniqueness for each one by looping over this nested loop. And this is a pretty good approach to getting our deck of cards. So that is a deck of cards. So we have that. Okay. Well, what about, I mean, it's great to open up a fresh deck of cards, but when you do that, right, you open up your fresh deck of cards, and you have like the jokers on the outside, and you have that one information card that advertises other products from Bicycle, right? And then you have your deck of 52 cards. You're just going to deal them out. You shuffle them, right? We got to randomize them. Yep. And so I think remember from yesterday, we had a library we used, right? And that was the random. So we can import that again. It's probably going to be pretty important. And so the random module actually has a method in there. I think it's we can do shuffle. It's the random.shuffle, and it just shuffles a list in place and returns nothing. So I don't have to define this as a new list. I can just say deck of cards right there, and then I can print, or I can just call it again, and now it's shuffled. And I can run that, and you see you get a shuffled deck every time. All out of order. Oh, yeah. Yeah, we could put the actual shape in there, right? It's like the what's it called? Is it Unicode, right? Or something like that? Yeah. Cool.
Hi, what are some other things that you can, like with the import random, what are some like brief examples of other things that you can import, if that makes sense?
Yeah, I can actually show you that. Let me add another code block. So let me remember what it is. I think we'll just go to Python libraries. Okay. So this is a list of a lot of the Python like libraries that are already included with Python. So when you install Python, you're actually getting all these, but they're not activated. So let me make it a little bigger. Yep. Yeah, Jason just put it in there. It's the Python standard library. So it's the same link that I have right here. So yeah, so you can look here, and there's a lot of power in this already. And you also have third-party libraries too. So you have those as well that you would import. You have to download via like pip or something. And when you go into Platoon, you'll learn about all that. Pip and installing environment, everything else. We're not going over that now. We're just sticking with mainly native Python. But there's like pretty print, so not just print, but pretty print, which will allow you to print data in a more presentable fashion. You've already seen, it's random somewhere here. Multi-processing is one that's pretty good for doing things in parallel if you're processing a lot of data. Date time, yep, that one's pretty important. The OS module, so that's like using the it's going into your operating system and grabbing paths for your files and stuff. I've used let's see, Pickle before. the glob module. That's, you can get path name pattern expansions. The it's like the shell utility, this one here, I've used that one before. Here's random right here, so it's more of like mathematical stuff. You have the math module. So there's a whole bunch. And you can take a look at these. I mean, these require studying on your own or just playing with the library and seeing what it can do. You can find, again, those websites, W3 schools, those will tell you all about those too as well. So you can get them in a, instead of looking through the manual, which of course is the most information dense, geared towards developer type instructions. You can read the manual, or you can go to something that explains the manual easier for, if you're learning, it's probably easier to go to W3 schools or any other tutorial site to find information about it. Okay, so yeah, and there's a command you could type. I just can't remember what it is, where you can actually see all the Python libraries right here, but I just can't remember what it is right now off the top of my head. So cool. So we have a deck of cards, which is nice, because now we can just grab, if it's already shuffled, then we can just grab the first 5 to give ourselves a hand, and it will be, a nice shuffled hand. We don't have to worry about like dealing it out like a poker deal, because we're just concerned about getting a hand and evaluating it. So really, we can say then hand, or we can even say poker hands. Let's say hand equals hand equals deck of cards, and we can just say 0 0:6. So we can take a slice of that, and that's what hand equals, and we can print hand. Let me see. Oh, we got too many, right? So we need to do 0,5. So we're thinking we want to do up to, but not including 5. We start at 0. So we have too many cards there. So let's try again. There we go. Now we have our correct poker hand. So that's what we're working with. So we have our poker hand now. So we kind of already said, okay, well, we need the cards. That's probably the most important thing. And then we also have the poker hand. And by looking at this, we can see that we have a high card hand. We don't have anything good here. We don't have the same suit. We don't have any pairs. They're all unique for the values. So that's a pretty, I mean, it's a high card hand. It's a pretty good one. It has, ace and king. So that's pretty good. If you were going against other high card hands, you'd probably win that hand. But you wouldn't win it against any other pair. So cool. So now we have a hand. So we're already booking, and now we need to evaluate it. And so we don't know how to read this ourselves. We have to rely on our Python program to do it for us. And so that's our next objective. And so now we got to think, okay, well, if we want to evaluate this hand, how will we go about that? What would we be looking for? And if we think about this, I mean, do we want to maybe start with looking at the like just going up in rank? So let's start like looking for a pair first, or maybe looking for a straight. How do we want to begin? Oh, there we go. Jason's putting the standard library in there and getting all the getting the output. So um so is it, if we think about it, like, we think about the hands that we had, would evaluating for some poker hands be easier than others? And then what data types could we, or data collection types could we use in our favor to maybe evaluate? Do we want to use a loop to look through our cards and make determinations? These are all the questions you'd be asking yourself, like, how can I evaluate these cards uh, to look for certain signs that would that would point me to a certain hand? Or do you just want to check through them all systematically? Maybe make a bunch of functions, and we have our pair function, and then we have our three of a kind function, our two pair function, and we can write a function for each one, and maybe call them all, and then whichever one comes out with true, that's the hand we have. Could we do that? There's all sorts of ways we can probably look at this, um which would be the best way. Do you maybe want to start with that? Maybe write like a function to check for a type of hand, and maybe build from there. We probably don't need to define the rankings first yet, until we're doing like hand comparison. We may, if we're looking at maybe for like a straight, right? Because we need to know whether like the ace is high or low. So maybe we do need to look at the rankings first. But Jason also says maybe we can look for a flush first, because we're just looking for the same suit. So let's try and write a function that just maybe takes the deck in and checks for a flush first. So we could probably do that first, and then we can build from there. And so we know we have our logic to maybe create the deck of cards. And so maybe we can wrap this in a function too, like the deck creator or something, right? Or deck of cards generator, we name it whatever. But let's start with a function that checks for a flush. And so when we write a function, when we're defining a function, we start with the def keyword, and we name the function that's something descriptive that tells us what it does, right? In this case, we probably want to call it like is flush, or yeah, probably is flush is good. So flush. And then we need to follow that with the parameter, the optional parameter. So we need to have our parameters. Do we need a parameter to go into the function? Okay, so the cards, right? So we can just say the cards. So we do want to put an input, because we need to check our hand if it's a flush. And if you don't give the hand to the function, then it won't know what it's evaluating. And so yeah, we want to feed our cards into the function, and then what do we want to get out of the function? And Jason says, so like output, right? We need something for the output. So we want to return something, right? And Jason says like a Boolean. So what's a Boolean again? That's true or false, yes or no, right? And we're saying that we're defining the function as is flush. So is flush, and the output is true or false. I think that's a pretty fitting name then. And then the response is a yes or no. So we can say, okay, so we want to return our result. You know, we can define result as a Boolean. So let's do result equals false right now. So if I ran this on my cards, you know, it wouldn't even look at the cards, but it would return false. So even if I did have a flush, that wouldn't work. But right now I'm kind of setting some placeholder stuff in there, because what we want to do is write code, write logic in here that will trigger result to be true if a certain condition is met. And so so now we're going to take a look. Okay, so we have our cards. And so now how do we look at the cards themselves? So right now we just have a list of cards. We're putting this into the function. How do I look at all the cards and look at the suits? So we can use the print, like we can, oh, so you're saying calling the function, right? So we need to call the function, but inside the function, how do we look at each card? So we're going to feed it a hand, right? So when we call the function here, like we can say is flush, and we can put our hand, right? Our hand that we made. So we can feed it the hand, and whatever the hand is, we can feed in there. Right. So the hand will go in here as cards. And then how do we look at every single? I mean, now we're inside the function. So we're actually writing out what the function's doing. We're not going to care about what's inside the function once we're done, because we can just call it to return. We want to make sure it always returns the correct result if you have a flush. But how do we determine if we have a flush inside the function? What tool will we use to look at each card that you learned in this course?
Talking about the loop, like the for I in, I can't see what we're feeding in there.
So a for loop. So maybe like, so we can look at like, oh, go ahead. I'm sorry, I didn't hear you.
I'm saying like for I in cards and
So for I in cards, or maybe for card in cards.
yes.
Okay. So for card in cards, and we can then, you know, what do you want to do with that? Is there anything we want to do?
Probably print cards or print card.
Okay, we can start that and kind of see, you know, what we have, right? Because we know so we want to make a loop, and you know, we're calling it with hand, so we can do that. And then yep, it prints the card. So yep, we are printing the card. But you know, I think what we want to do is maybe we want to go further. We don't want to look at just the card. In fact, we care about the card, but we really don't care about what's everything on the card. We only care about one thing on the card. And there's two things on every card, right? This is a card, right? And there's two things. There's a value and there's a suit. When we're looking at a flush, what are we only concerned with?
All right, I gotta go back to see what a flush looks like.
Wouldn't it be those 4 cards? Isn't it a 10, a ace, a king, and a queen? No?
So the flush, right now we're evaluating for a flush. What do we care about?
Oh, 3, 8, the 6,
we-
the king, 10.
Do we care about the numbers in a flush?
No, it's just the if there's diamond cards or
Diamond.
The diamond. So we care about the suit. There's only 4 suits, right?
Ah, yeah, 4 suits. Ah, yes. Thanks, Aaron.
Yep. So we have the card, and so all we care about is the suit. And so if we were to, what if we wanted to only print the suit of every card? How could we do that? Just because we're going to go to the same idea of printing something, right? So how can we print just the suit of the card? How can we access that with Python? And we like take for example, we did this, right? We print card and we can run that, and that's what we get back, right? But I don't want to see the 6. I only want to see the C. How can I do that with this command? Is there anything I need to add to card to do that?
You can do selecting the second character.
Right, because it's a string, correct? How would I select just the second character?
You do the brackets, and those will be from 1 to 2.
So print card 2.
No, card 1.
Oh, card 1. Why card 1?
Is that'll be your suit? Does
Oh.
not, that should get the actual suit.
Okay, so it would be this one. So what if I wanted to print the 6 or the K or the, like, how could I do that?
Should
Would
be
be-
0, right?
Oh, 0 indexing. We start at 0 indexing. Okay, so doing that. Look at that. So we do have suits, right? So print card 1. So that's how we access a suit. And so okay. So we have that, and we can see the suits, but we want to evaluate the suits, right? We want to see if they're all the same. We can see that when we print them, they're not the same, but Python's not evaluating anything. What data set could we use maybe to evaluate something? So maybe we should make a variable called like suits or something. And we could put it into like maybe a list, and we'll get a list of all the suits. Or maybe what if we put it into a set? And then we put the suits into a set. So here, instead of printing, maybe we can say, like, how can we add something to a set, right? So suits. How do we put things into a set? Like, you know how we add things to a list? What's that method we do to add things? Is append, right? Do we append things to sets? Okay, Jason says add. So suits.add. And then we can just add card at the index of 1. And so what if I add multiple clubs to that set of suits? How many clubs would be in there? Because if we remember we talked about sets in the unordered data structures, and we said, hey, sets are good for deduplicating things. And so if we add all of the card suits into our set, then we can just check to see the length of suits. And what if the length was only 1?
Then you only have one type.
So if we printed that, right? So we know what our hand is because this is our hand right now. It doesn't change until I run this cell again, right? And then I run this one again. So we're always going to have this hand for now, which is fine. Right? It can be static, right? So I don't know if I even need this right now, but we can keep it. So right now we can run that. And it says the length of, after running all 5 cards, because we always feed it 5 cards. So 5 cards are going in, and then the suits are being evaluated and added to our set. And then we're checking the length of the set after that loop runs, and we're getting back a 3. And I think we can deduce why we're getting back a 3 if we take a look at the suits of our deck. We have the club, we have a spade, we have another club, and we have a heart, and then another heart, right? Sets only take unique values, and there's 3 unique values there because we're getting the club, the spade, and the heart in there. And so if the set is coming back with more than one suit, then we can safely say we don't have a flush in our hand because we have different suits. So we can say if only one, if the length comes back as 1, then we know we have a flush. And so maybe we can put some logic in here then at that point and say if length of suits equals 1, we can say result equals true. Then we can return the result after that. And so I can print this function call now with our hand, and it says false. But if I were to feed it an actual flush, let's try that again. There we go. And just change this all to heart. Now we get true. So it looks like this is working, feeding it, that or our randomly generated one. We can go back to hand, and then we can run this again. And we don't have to actually call it anymore. We know it's working. So we know it's working now, and then I can get my hand. You see we have a different hand now. And then I can run this on hand, and it comes back as false. I can run these. I can do it several times. And we can see that we don't have a flush every time we run this. Almost got a flush here, right? Missing one. If I ran that, still false because there's an H in there. So it looks like we can at least, we can measure a hand right now and see that we have a flush. Any questions on that so far? We've already done a lot. We imported a random module, and with lotteries and poker, random, having some sort of randomization is of course important. So we have that module, and then we built a deck of cards. And we built the deck of cards by establishing first an empty list. And then we said, okay, well, we have unique suits. We have diamond, heart, spade, and club. And then we have unique values with ace all the way up to king. We haven't established like value of the cards, right? We haven't, at least for hand rankings. We can later, we will. But right now, we just want to get a deck of cards first. And so then we said, okay, well, we have our suits and our values. I just need to loop over one of these, and then inside of that loop over the other one, and then append the combination of those two as the loops happen to make a deck of cards. And then we use a random module to shuffle the deck of cards. This is very convenient and very clean and easy code to remember, like random.shuffle, and then our list of cards. That's actually shuffling, just like we would in real life. Shuffle our cards. And then we said, okay, well, we can make a hand by just grabbing the first 5 cards of our shuffled deck. Even though that's not realistic for dealing, right now we're just trying to evaluate a hand. So getting the first 5 cards in a shuffled deck would be good enough for now. And then we said, okay, well, let's start evaluating the cards and seeing what we can come up with. And so we decided, hey, let's make a function called isFlush, and we're going to evaluate the cards. And how can we do that? Well, now that we have it done, we don't have to think about how we did it before. We just want to make sure it returns a result. But in this case, we're concerned right now. So we're going to go over the function. We want to put in the cards, our list of 5 cards here that contains strings of our card value and suit. And inside the function, we want to kind of preset our result to be false initially, right? And if a certain condition is met, we want to trigger that to, change it to true and then return it. If that condition is not met, then we'll return the preset condition, which is false. And we also want to make another variable called suits, because we want to just look at the suits. We don't care about the values at all right now. And we want to make that empty set. And we want to start looping over the cards and adding just that the suit to our set of suits. And then just after that loop runs, check the length of the set. And if it's 1, then all the suits are the same. And we can trigger it to true and then return it. And so that's what we did. And so right now, we can check to see if our hand is a flush at least and knock out that one. So we can check to see if we have a flush. But we have a lot of other hands to go. Let's do that after the break. So let's take a 10-minute break and come back and resume. I'll go ahead and stop sharing or stop recording. Keep going. Okay, so welcome back from the break. And we are resuming our poker hand evaluator. And so before the break, we established that we have a deck of cards, and we were able to also get a hand. And we also wrote a function to check the hand if there is a flush. We determined that that's probably the easiest thing to do because we're just checking the suit. And so we can go with that kind of logic where we can maybe build out each function to check for things, right? So we have isFlush. So maybe we can create another function and check for another type of hand. Which hand do you think would be ideal to check for next? Yeah, maybe royal flush, right? That's like the most restrictive of them all, right? We have royal flushes. You can only have, there's only 4 different sets of cards you can have to have a royal flush, and that's, of each suit, and that's 10, Jack, Queen, King, Ace. Yeah, we could do that. So maybe we can call a new function called def. We can say is, you just call it royal, right? And then what would be our parameter? We do cards, right? So it's same thing. It's the same thing as the flush. We can just check there. And so, okay. And okay, so now we got to check. We got to check for so we have to check for 2 things now. We have checked for a flush, which is already done with isFlush. So yeah, we can then so maybe, well gosh, maybe we can use the output of isFlush to kind of already take care of things. Or we can just check for, So if we went through all these functions in order then and have a bunch of trues or false, then we can like, we can check to see if, is flush is true. And then we can check for a straight at that point and check for only a certain straight. But yeah, we have to have 10 jack queen king ace to get a royal flush. So how can we start that process? And Miguel says an if statement to see if it's a flush. Okay. So we can say like if, so we can do like this, right? Is flush cards like that?
I was thinking more like condition that if it's true, then to check, if it has the 10J QKA.
Yeah. Yeah, so this actually, but like right now, it's kind of cool because we already have a function that does checking for a flush, right? So this could be our first check, like to see if it's a royal flush, right? So is it a flush? Because it has to be a flush if it's going to be a royal flush. So if this evaluates to false, then we can return false. So we can say return or not return result equals false, right? And then this could be one thing to check for. And, in this case here, right, is flush. What I'm doing is, this is the same thing that Daniela is asking. If is flush equals true, but you're missing your function call, right? But this right here is saying that same thing. I'm saying if the return of is flush, which will be true or false, right? If is flush, I can then go into further logic to check for the straight, right? If not, otherwise, and then I can do like, so let's do like a pass for now or something, right? It doesn't really matter. And then I can do else return result. Or I don't even have to set that. I can just return a Boolean value. So I can do that too. So I can say return false. Right? If it's not a flush, I can return false right away. Boom. But otherwise, I can go into some nested logic to start checking for a straight. So, but it's not just any straight, it's the straight of those exact cards. And so maybe we can just write logic to check for those 5 cards. So if we know it's a flush already, then maybe we can just evaluate the cards and see if they are in there. And so maybe I can start with like a set. So I can say, let's say, we can call it the standard. So standard equals, and I can just make a set of ace, king, queen, oops, jack, 10. And then just like I did with the flush, I can get a set of the values. And if the set of the values equals that standard, then I know I have the correct thing, the correct straight for a royal flush, and then I can set my result to true at that point.
But then you pretty much copy and paste the for cards in cards, suits dot add card instead of a 1 be a 0, and then put the if whatever you add in there to the suit equals standard to be true.
Yeah, I don't quite, if you can put it, you can put it in the chat, like what you're trying to do, and then we
So
can
like the
copy and
box,
paste it.
yeah, the code box you have above define an is flush. You see where it says for card and cards,
Uh-huh.
like pretty much copy and paste that on the knees.
Oh, I see what you're saying. So like
Instead of being
this,
a
right?
1, be a 0.
So for cards and cards, then I can do like, and then I can make values equals set, right? And then suits or values add card 0, like that.
Correct.
Okay. Yeah, and then I can check here if values equals standard. Or I don't know if this will work actually. We'll see if it does. If it may. But if it doesn't work, maybe we can use one of our set methods when we're comparing two sets. Do anybody remember those? All the different set methods that we have?
We're talking like the one that talks about union and stuff like that.
Yeah. Do we have any of those? Maybe we can then compare two sets. And if we get a certain result, we can end up with a true. And then here
I
I
think it'll
can
be
say
intersection.
so intersection. Yeah, let's go back and take a look. Unordered data structures.
Appears on both sets, A and B.
Okay, right here, right? Ah, so like, yeah, so if I can do like the symmetric difference. Oh no, it would be the union. No, it would be the intersection. Yeah, intersection. If the intersection, oh, so I can do the intersection of those two and check the length. Right? So if I do the intersection of standard and values, and if the length of that is 5, then I know that they match. But I could also try this first and see. Like we can try that real quick. Let's just make two sets real quick. My set equals my other set. I do this all the time when I'm actually like coding. Like I will do quick tests either in a Python like console. And let's actually do it in different order. So 5, 3, 4, 2, 1. And then my set equals my other set. True. So we should be good to go. That's what I'm doing here. So values equal standard. I'm doing the same thing as doing the intersection, but I'm just gonna check for equality because that would be the same thing. Did y'all follow along with what I just did there?
Can you just break it down one more time?
Yeah, sure. No, that's
Yes,
exactly
please,
why I'm
yeah.
asking the question because some of y'all may not be following along, and I wouldn't want to leave you. So starting at the top, right? I have defining my Israel, and I know that a royal flush is a flush, so I need to check if it's a flush first. And so if it is a flush, if me calling this function comes back as true, then I know I have a flush, but I need to do further investigation. And that investigation is checking to see if I have ace, queen, king, jack, and 10 as the value of my cards. And so I went ahead and made a value called standard, which is just a set of those values. And then I'm making a variable called values, which is an empty set. And then I'm going to add cards to that set. I'm going to add values from my hand. And so I'm looping over my cards and I'm grabbing the first index of that string. So each card is a string of 2 items, right? It's the, the ace of hearts or whatever, right? And so I'm going to grab that first value. So I'm going to grab the ace or the king, whatever's in my hand. And I'm going to add it to this value set. And then I'm just going to check to see if values equal standard. If I grab the 5 cards in my set, the value from there, and it matches this, then and it's also a flush, I know I have a royal flush at that point. And so I'm going to set result to true, or I can just return true. I can also do that, but let's go ahead and do it this way. Result equals false, result equals true. And then I can then at the end of this one, I can return results. And then result here. So just looking at this logic, I'm setting result to false first. Going into here is a flush true? Yes. Okay, go through and oh, yep, I also have all the same cards. Result not equals true, and I'm returning a result. If I don't hit this, I'm returning a result, which will be false. Because I will never have a chance to trigger it to true. And so we can then, outside of doing like trying to get a royal flush with our random hand generator, which will probably never ever happen, right? Because it's like a 1 in I can't, it's like 2,000 something % chance of getting a royal flush in a hand. So we probably won't see that when we're going through that, but I can just call this function with a royal flush already. So I can just say print is royal, and then I can just feed it a list of cards. So let's start by getting our existing list of cards at a good starting point, and I can change them. So I can do that. And then I can say 10 clubs. Let's do an ace. Let's do a king. Let's do a queen. And then let's do the jack. And let's change that to a club. Okay, so now we have 10, jack, queen, king, ace of clubs. So this is a royal flush, but we want to see if we get back a true or false. So we can even give it a couple test cases like you've seen in the replit things where you'll have like different test cases at the bottom. I can just call this function over and over again and maybe make a small change when we don't have a flush, or oops, we don't have a royal, not ace 4, a 4H. There we go. So now this case, we don't have, or this would be a club. We do have a flush, but not a royal flush because there's not a straight that we need. And in this case, we do have the straight we need, but we don't have the other suit. So both of these should return false. And if I run that, oh, all 3 are false. That's no good. Something happened. So something's not working here then.
Can I ask a quick question?
Sure.
For the where you have if is flush cards above the standard,
Mhm.
why wouldn't you put if is flush cards equals true? Like why would you write that out?
So like that?
Right.
Okay, let's try that. Still not working. Because the return of that, right? So if I did this, right? Let me just go ahead and copy this line down and comment this out so I can get back to it. So what if I did this? What would happen if I ran this script? So if I ran the script as I wrote it here, what would happen after line 4? Always. Would I ever go to the else statement?
No.
No, right? Because if true, which is saying, hey, if if this statement is true, which it is because it's actually true, it would go into this, right? What if I said if false? Then if you see how the ID is already telling me like you will never go here, and this saying code is unreachable. This is kind of my linter saying that, right? Pylance. It's saying this code is never going to be reached ever, because you're defining false right here in your if statement. Like it's always going to just never go here because it's false. It's going to go to the else statement. So what I'm saying here then, what I'm saying here is I'm calling this function right here in this line, and it's going to give me back something. It's going to return a result, and the result is either going to be false or true. So the me calling this function serves as that true or false, but it's dependent on the results of this function, which is why the IDE is not yelling at me. It's saying, hey, this may be true, may be false. I have no idea until it gets called. And so it's not going to scream at me there. But we do have a problem here. So that's just a way, it's just a way of saying like, hey, like I'm introducing Boolean logic, but probably not in the way you thought I was. Like we've seen before where we kind of have our Boolean statement. I could do this, right? I could write that and it would be just fine. Because the result's going to come back and I'm going to evaluate, is true equal to true? Okay, cool. Going in. Is false equal to true? Well, no, it's going to go into else. That is completely acceptable as well. I'm just shortening that because this is going to come back with a true or false anyway. Do y'all see that kind of logic? You're going to see that in code you see out in the when you start looking at code out in the wild, you're going to see stuff shortened like that. Because this is still a Boolean statement. It's just you have to run the function first. And that kind of enhances my line of thinking when I say, hey, I don't really care what's happening in this function. I just care about the result. And the result is going to be a true or a false. And I'm getting it back. And that's kind of what I'm putting in there. And that's kind of why it's written that way. But for here, I'm running into some sort of issue where I can't see something. And so, yeah, maybe I should throw some print statements or something in there to kind of see what's going on. And so, yeah, let's go ahead and print values here and see what's happening. Why, like, after this loop runs, I should have 5 cards in there no matter what they are.
In print values, I feel like it's only picking up the 1 of the 10 on the string where it says 10.
Mm-hmm.
I feel like it's only picking up the 1.
So it looks like, Ooh, I'm not even, is royal, the cards. So I'm not getting in there. I'm only getting to the else statement. Because I do have a flush. Oh, you know what? We have an issue. Does anybody see what the issue is? And the issue is not here. The issue is here. I take that back. No, there's an issue. And
Is it the
nope.
brackets?
But no, see, it's not printing. So the issue is definitely here.
Is it the brackets that you have down on the print statement on the bottom?
Right here.
Yeah, the blue brackets.
So that's what listen, that's the parameter I'm feeding into Israel. So I'm kind of calling the function by itself. So I'm giving it cards. And no,
like what?
it is. The issue is here. And watch what happens when I do this. And if anybody can point out what the issue is, what's going to happen? What am I going to see when I print? If I print suits here, what am I going to return? What am I going to get back with this print statement? And I can actually put this into my flush call. Oops. Let's put that in there. What's going to print here? It's an easily fixed issue, but it's just something that we overlooked.
It has to do with a 10.
It does.
It'll be like 0 AAA or C.
Right there's the issue. So it's not properly evaluating for, so instead of a 1, which we want to get the second one right, we want to get the second or third value depending on which one we're looking at, because we have a 10 in there. That's 3 characters. We just need to say -1. That way it grabs the last thing, so it's always going to be the suit at that point, because the suit's only 1 character. So that was the issue, I think. Hopefully. We'll see. There could be other issues. I always have problems with my code when I first type it. So, well, darn it, it's gonna run into this issue here too. Because now we're trying to get the first one, but we don't want just a 1. We want the 1, 0. We want both. So we need to think about that a little more. Because right now our set will probably not work. But at least we can see if we actually get in there. So print here, right? We can put that in here again. And we can comment that out. We've already checked that. So at least we're getting this print statement here. Well, oh, let me run that again. There we go. Okay, so now we're getting here. So we're actually getting into the logic. So this is working. And we're actually getting into here and we're printing it. But see, we're getting that. That's no good. That is no good at all. So we're getting falses because it doesn't match the standard, which should be that. And so that's ugly. And so what if, so, but we can tackle that here. We don't have to like give up because there's only 1 card really that happens to, right? And that's the 10. The 10 is the only card that has 3 digits. So maybe we can just throw that functionality in here. Like we can say, if length of card equals 3, we can do values dot add card, and then what will we put here? So what I'm saying is, if the length of the card is 3, then we know we have a 10 of something, right? And so we want to add that to our values because if it's there, we want to definitely add it. So values.add, what would I put here then? And I give you a hint, it'll look like this, but slightly different. Patrick says 0, 1. So we want to do like a slice, right? I think we could probably do that. That will work. Or we could do values.add card 0 to 2, and that will do up to but not including. So that would be the first and the second index, but not the third, because up to but not including the index 2. Both of these would be the same exact statement. But let's go with the cleaner one here. It says you omit the first one. You're putting it in there, but it starts at 0 because you're putting the colon in. It's up to but not including the last index, which is the suit. So that should work. And then I have an else statement here. And so if it's not 3, then it will just always add the card at the first index because it's only gonna be 1. Does that make sense? Ooh, I'm getting some truce. That's a good sign. Print that, get rid of these print statements now. You don't need those. So run that now. Okay, so true, false, false. Okay. It looks like we're in business. It's seeing when we have a royal flush, and it's using the logic from the flush is flush to then build on and do a quick checking of the standard, because this is the only standard for a royal flush. This would be acceptable in coding if you have something that's so restrictive, right? That you only have one unique set. You can kind of hard code something to check something against and be fine if it's the only case. Otherwise, for straights, we don't want to do that because we can have all sorts of different straights, right? Too many that kind of count. So we'll have to do another way of checking logic. But there we go. I think we've successfully, now we can check to see if we have a royal flush, and we can check to see if we have a flush. Okay. Cool. Let's get rid of this nonsense here. Let's clear out our outputs and then we did our checking of that. We can go ahead and get rid of that as well. Any questions so far? If we look at, like, that was kind of a weird edge case that we only identified by kind of testing our code and checking it after, and then realizing, oh, we have this weird edge case with the 10, and we have to consider that for later evaluations as well. What do we want to check next? A straight flush? Kind of build on that logic there. Do you might want to check any for maybe pairs or full houses or anything? We can go for a straight flush, that's fine. We may want to check for a straight first or something, and then build on that, right? Because we already know we can check for a flush. So right now, the way we're defining these, it won't matter, right? Because each function is an independent entity, right? we're checking for something, right? But we can use the output of certain functions inside of other functions, which is what we're doing with the Royal. And so that's kind of where I'm getting at. Like, okay, so if we check for we check for a flush, then we can check for a straight. Yeah, so we can use results from other functions. It doesn't really matter the order right now. We're just kind of building out. But if we're we want to make sure that when we're building, like, we don't inadvertently, like, well, I guess it doesn't really matter because we can build the code out and then be like, oh wait, this is actually the same logic for a straight, and we can then just change something really quickly. We could do that as well. So building functions on one another. I don't remember how to play poker, honestly, despite having worked at casino before. Well, I mean, if you never dealt poker, I guess. But yeah.
Yeah, I wasn't a dealer or anything. I did multiple casinos in South Mississippi.
Oh, really? I love that area, man. I was like,
You were at Keebler?
I was at Keesler, and like I had my eyes set on returning there, like, for retirement, because I was going to go teach at the Weather Schoolhouse there, because that's I taught in the Air Force, and I was going to go back and work as GS9 until my sister turned me on the tech, and then I was like, yeah, the money's better in tech, so I'll probably just do that instead.
It is better. Biloxi, I mean, that's a pretty sleepy area. It's definitely built up over the years. Last time I was living there was like 2006 or 7, so yeah.
Yeah, I was there from 2008 to 2012. So
okay.
Yeah.
I was there in 99. I had no desire to go back.
You never wanted to go back? Or I didn't quite hear what you said.
As I was there in 1999, and I have no desire to go back over there.
Oh.
Yeah.
I don't know. It's either you love it or you hate it. And I really, really liked it there. But I'm here in St. Louis. I'm probably here to stay. I'm in the Illinois side, but it's just, I mean, we fell into some good jobs, and I think we're just gonna stay here. I can always fly down to the coast. There's pretty cheap direct flights on Allegiant Airlines, and they have really good veteran benefits. So they're like an ultra, they're ultra like budget, but they have good veteran benefits where you can still get like a bag for free and stuff like that. And the flights are direct. So I could.
Where do you fly into Gulfport or?
Well, so as far as like they go to Florida, so I'd have to go to Florida, but the Gulf Coast in Florida, and I could. I mean, they're direct flights, so I could book a flight and be on the beach in 3.5 hours if I want to. So, on certain days, anyway. But all right, let's dive back in. Well, you know what? Let's go ahead and take a break. Because it's already 7:50. Let's take a break, and we can come back at 8 and then get a full hour of coding the rest of this. So, yeah, the T-Rex is cool. That was my first job I worked in there, and I really liked working in there. You're right downtown. You have some good lunch options. So yeah, let's go ahead and take a break, and then we can get back into diving into this poker evaluator. All right, welcome back from the break. We're going to dive right into our other functions. We still have a lot of hands to check for, and hopefully we can get through all this in the next hour. But don't fret if we cannot. I can always share this code in Slack. You'll still be part of the channel even after the class officially ends today, because you'll still be doing your application, everything else like that, and I can share code, and you can still look at solutions there. And you can always reach out to me. I'm still on Slack, and so you can always reach out with any questions as you go along in your coding journey. And that's anytime, as long as you're part of the Platoon Slack, you can always reach out to me. You can reach out to the general channel, and there's other channels for asking questions and stuff like that with Platoon. So this isn't the end of your time with Platoon, even if you're not necessarily a student right away. You can still ask questions. So awesome. So let's move into a straight. I guess we can check to see if we have a straight. And then I think actually, if we check to see if we have a straight, and then we can then take the output of that, right? And then check for a flush, then we would know if we have a straight flush. So if is straight is true and is flush is true, then it's a straight flush. So maybe we can just write is straight and check for that. Because I think checking for a straight will be pretty difficult. We may spend a bit of time on this one, only because we now need to see if we have consecutive cards. And that could be a bit of a challenge for us right now because we're just dealing with strings. And so we may need to assign values to these cards and check to see if they're sequential or some other way. We have to figure it out. So yeah, let's go ahead and dive right in. So just like any other function, we can just define our function like is straight. And then we feed it in the cards. And now we can start building our logic. And we can probably start with our result. So we always want to, define our, we don't have to always do this, but this is a pretty good practice to go ahead and define our kind of like our variable that can return as a result. This is pretty common practice. And so we're doing that. And so now we have to think, okay, how are we going to evaluate for a straight? Is there any how can we do that? How can we assign values? How do we know when we have like 3, 4, 5, 6, 7 that's a straight? And what if it's out of order? And like how can we tackle all that basically? And I think, to be honest, like this is probably a good time to make something that does assign values. And I believe at the very beginning, someone mentioned about making like a dictionary. Who was that again? I thought I saw that. I can't remember who did. Let me see if I can go back up in the very beginning. A dictionary. So Danielle did. Okay. So Danielle suggested that. Okay. And I don't think Danielle is here anymore. That's why I didn't get anybody speaking up. So yes, we can establish some card ranks, right? And so we can say, okay, well, we can just have, like numbers, for example, as our keys. And then we can have like, or let's say like, let's start with 2, right? So 2, and that is 2. I don't know why it does that. It's so annoying. Then comma, and then 3, 3, comma, and I'm just going to go A. Right. Let's just keep going. 10, 11, 12, 13. Jack, queen, king, Then, what are we gonna do for an ace? Maybe we should flop these. Maybe we should have the card ranks as the key because it's a string, it can be immutable. And then for ace, we could have like a tuple of like 1 and 14. And that way we can check for an ace because ace is like a special. Ace is like a special value. I mean, I guess I could also do 1 ace and then 14 is ace too. I guess I can do that. Because you can have repeating values. Oop, let me put a comma here. Okay. So I have a dictionary of card ranks, and it goes 1 through 14, and I'm putting ace in either the 1 or the 14 spot because ace can be high or low, and it's high for most hands, but it can be low in a straight because you can have ace 2, 3, 4, 5 and have a straight. So okay, so I have that. So now I have some sort of ranking where I can rank the card values based on the first part of the card, right? So the values, and then you have the suit. And so I can possibly use that to determine if I have a straight. How could we determine if we have a straight though? Anybody have any suggestions? I think I actually like doing the keys as the card, and then that gives you a value because that would be easier to grab. So I think I'm going to flip these around and go with let's get rid of that one. And we will go with 2 like that. So we have to redo it all, but that's fine. It won't take very long. All right. There we go. And then this will be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And this can be a 1, 14. Okay. And so what I'm doing there is I'm making a ace equal a 1 or a 14. So it's like a tuple. And that gives me actually a couple of advantages because I can then check to see if the value of that ranking is a tuple, and then I know I have an ace and I can deal with that. But I think that would probably be a better way to establish my card ranks by using the string value as the key to access a value, and then we can determine if things are sequential at that point. And so yeah, maybe we can start evaluating the cards and using our card ranks dictionary to, the facts that we know about like sequential numbers, maybe we can figure out a way to write code to evaluate, whether we have a straight or not. And so, let's see how we can do that. So I think just like the other functions we had, we probably want to go over the cards and get the value, because with a straight, we don't care about the suit at all, right? We just care about the value of the card. And so maybe we should just start with a loop to go over the cards and get the values. And I think we can probably borrow the logic we have here, where we're checking to see if, oh darn it, I used Windows command again because I worked on Windows all day. Now I'm on a Mac. There we go. And then there we go. So for card and cards, if the length of the card is 3, I know I have a 10. I can then add it to values here. And I'm going to go ahead and make it a list. And I'm going to append it. Okay. So here I'm checking to see if the length of the card is 3, which if the length of the card is 3, I know I have a 10 of some suit. And I'm grabbing the slice of it to grab the 10. And I'm throwing it to my values. I'm appending it now, so I'm not going to make it a set. I'm going to go ahead and make it a actually, you know what? I think I actually do want to make it a set, and I think here is why. Now I'm thinking to myself, if you have a straight, that means the values you have are all going to be unique because they have to be in order. So, that could be one of the first checks right there to whether I have a straight or not, by checking to see if I have any pairs. If I add my cards and then I check the length, and it's not 5, I don't have a straight. Does that logic sound pretty straightforward? So I'm going to add them in there and then check the length. So if values, or if len values, so the length of values, which is my set that I've already added my cards to, does not equal 5, I can return result. And that'll be false because I'm not changing it. So right off the bat, I'm any kind of pairs, full houses, 3 of a kind, 2 pairs will be ignored already. And so I'm going to have now some sort of setup where it's all unique cards and maybe not in order. Okay. So at least I know I can test for that. And so what's next? So now I know if it's not 5, I return result. So then at that point, I know I know I have unique cards at that point. So then I can check to see if they're sequential. But now, see, I'm dealing with a set right now. So I have a set of cards, which means they're unordered. So I really can't check to see if they're sequential. So maybe I should cast my values to a list now. And can I do that? Can I cast a set right to a list? I think I can. I can always just check real quick. Equals. And then my list equals list my set. My list. Looks like it does it. And it kind of, I think, puts it in order for me right away. I don't know if that's true or not. Looks like it does. It kind of puts it in order for you already. It's interesting. Okay, so I know I can cast it. Now I have a list of values. And so how can I check to see if they're sequential? Anybody have any ideas? Is there a way to put them in order? Yep. Okay, so I have sort, right? Which when we do this little test, it looks like it already puts in order, but it doesn't hurt just to go ahead and do that anyway. So I can say values dot sort, and I can just do that first. And if you remember the sort method mutates your original list. And so, and the difference between that one and sorted is, so this one sorts in ascending order and then returns none. So it's kind of like a quick method to just change the order and you have it, you're done. If you use sorted, then you can actually return, you don't change the order of your original list. I don't really care about that. So I'm going to go ahead and just do a values.sort. And so now I have them in order, but I still don't know if it's 2, 4, 6, 8, 10 or something else, right? I don't know if it's in order sequentially. And I have to think, well, what's a way I can evaluate it to be sequential and, you know, where I have a straight. And that's where, you know, if we can think about how we can, determine, you know, what tools do we have at our disposal, what we learned in this course to check for that, to check for like a sequential type of data set. We already sorted in order, and so it should be ascending order as well. Yep, we sure can. We can check for min and max. So we can check for the min, and not only that, maybe we can even check to see if the last position is a certain amount higher than the first position. So first we sort it, right? And then we can say, well, let's say, for example, we have 4, 5, 6, 7, 8, right? So we sort it and we get the value of the first, so the first index. We can just say, hey, if the item at the first index or the item at the last index is equal to the item at the first index plus, so 1, 2, 3, 4 plus 4. So we could do that. But now we have to still sort the values. We have to sort the values based on the card ranking, not the values themselves. So right now, we're still dealing with strings. And the problem is, if we try and sort the strings the way they are now, we would be fine sorting them up to the queen. A K would evaluate as lower than a Q if we sorted it by strings. And then the A would go before the 10, but it will go before the J, but after the 10 when you're dealing with strings. So we need to actually not only convert it to a list, but we need to, before we sort it, we need to convert it to the values that tied to the rank, the keys and card ranks. So we have numbers to deal with. Numbers or a tuple. And so the tuple kind of throws a weird case in there, but that's something we can easily handle before we do anything else. Right? So so that's a lot to think about, right? So first we want to change our values. And we don't have to do it after we change it to a list. We can do it even before. But we want to say, maybe make a new list called converted values, and it's equal to an empty list. And then we can loop over our set. So for item in values, we can then say converted values dot append. Good Lord, these pop-ups. Converted values dot append card ranks at the key of item. So what we're doing is we're making converted values, and we're going over the item in our regular values. So this is a set. So number one, it needs to be a set of 5. If it's not, we will already have exited the function and returned false. So we're already in there. We know we have 5 items. And then I'm saying for item in values, I'm going to append to converted values the value for the item. So for each one, it's going to take a look and give me the value that I'm accessing with the key. So each one of those strings should be a key to append to converted values. And so I don't have to worry about doing that now. Now I'm just dealing with converted values, and I can do converted values dot sort. And I can sort them in order. And so now I should have integers in order, and then also maybe a tuple. And so what if we do have a tuple? What if we do run into an ace and we have a tuple in our converted values? I think what we could probably do is say, like if a tuple is found in, like if a tuple is in my converted values, then I can say, well, if the sum of the other values is 46, then I know I have a straight. How does a list of values of numbers with one tuple sort? How about we start there? So let's start with, I need a list. So 3, 4, 5, 6. Oh, let's actually do 10, 11, 12, 13. And then this is the tuple 1, comma 14. My list. Print. Let's do my list dot sort, and then my list. Oh, so there's an error. I can't even sort that sucker because I can't compare a tuple and integer. So that throws, I can't sort it then if there's a tuple in there. So maybe I can look for, well, I know I'm going to have this tuple in there, so maybe I can look for that first. So if one in converted values, so if it is in converted values, then I can then remove it and then get the sum of the remaining list. And if that's 46, I have a straight. I can do that because then I know I have 10 jack queen king and I had just had an ace that I removed. I can start with that restrictive set first. I can do that condition first. And then otherwise, oh no, I have to do an or because I can have ace 2, 3, 4, 5. So I can say if it equals, if I find the tuple in there, remove it. If it equals so 14 or 46, I have a straight. Because unless there's other is there any other combination where I can get 14? I can't have pairs, so it would have to be unique numbers. And it has to be 4 card. I don't think I can get 14 any other way. With unless I have 2, 3, 4, 5. Does everybody see that logic and how I'm coming up with that? Is everybody following along, or do you need me to explain? Okay, cool. Yeah, just interrupt me too. Just please interrupt me if it's not making sense. So what I'm checking for right now is I'm checking to see if, when I converted my values over, so I'm using the dictionary. So from the beginning, I'm getting my cards and I'm first checking to see if the cards I add to my set, if I have 5 of them. I should have 5 of them with a set or with a straight because if I have anything that's a pair, then my set won't have 5 cards. So there has to be unique values. So I'm first establishing that I have 5 unique cards. Then I have to check to see if they're in order. And the problem is when and I have to convert my strings into some sort of value system. So I made this card ranks dictionary with the actual card string as a key and a corresponding numeric value that I can use to figure out a math rule to give me consecutive cards, right? And the problem is my ace, if I have an ace in my hand, then whenever I convert my values to these integers or a tuple, if I have an ace, I have a tuple. And I can just see if I have a tuple in there. And if I do have a tuple in my converted values list, I want to remove it from my list and then check the sum of the other 4 cards. And an ace is only going to be, I will have a straight only if I have these 4 cards or these 4 cards. And remember, I've already converted to these values now on this side. So I can just say, well, if the sum of my remaining cards is 46 or 14, then I have a straight. And I can go ahead and set my result to true. But I still have to do my other logic for the straights that don't have an ace. But that should be easy too, because then I can just sort them in order and check the first item in my list, and then see if it equals if the last item on my list equals the first item plus 4, because that should cover any other straight that I have. 9, 10, Jack, Queen, King. 9 plus 4 is 13. So the key is to sort them in order to then check to see if I have it. But first I have to deal with this unique case of having this tuple in here. And so all I'm doing is I'm seeing if my converted values has a tuple in there. If it is in there, I want to remove it. So converted values dot, and I think it's remove. Yep. Remove, and I'm going to go ahead and give it 114. And then and so once that's done, I can say if sum converted values equals 14, or sum converted values equals 46, result equals true. So what I'm saying is when I convert, I'm looping over my values, which is a set, and I'm converting it to a list, because I made this empty list called converted values, and I'm looping over the set of values and appending it. I'm appending the reference to the value using card ranks. So that's how I'm converting it. And then I'm checking to see if I have an ace in my hand, because this will show up in my converted values if I have an ace in my hand. And then I'm removing that from my list and checking the rest of the values if they equal 14 or 46, because they should all be integers at that point. And then if that's the case, I have a straight, and I want to return true or change result to true. So way up here, I'm changing result. I told you it'd be a little more complicated checking for a straight. And then I can say else. I can then sort my converted values. So converted values dot sort. And then I can check if converted values at the index of 0, or no, at the index of -1 minus converted values at the index of 0 equals 4, result equals true. Okay. And then return result. That's a bigger function. And so I probably I probably fired through that quickly, only because for the sake of time, we're at 8:36 now. We haven't finished all the functions. We probably won't, but I will share the other functions as well with you in the chat if we don't get to them. But here I have now is straight, and I'm getting my cards. My cards is a list of cards with those strings, right? And I'm setting result to false, and then I'm setting a empty set called values. And then I'm looping over the cards I'm bringing in. So just like we saw before with something like, I think I got rid of it all. Let me run that real quick. Something like this, right? So I'm grabbing that, and I'm going to go ahead and copy it and go down here. This would be is straight. I'm going to go ahead and call this function print. I hope I have no errors in it. I always do. So we'll see. Let's start with king 9. Let's do a 10 here and an ace here. Okay. That should be a straight. 9. No, it's not. 9, 10, jack. I need a queen. Queen. Okay, so 9, 10, jack, queen, king. I need to have a 10, jack, queen, king, ace. So get that ace there. I need to have ace, 2, 3, 4, 5, and I'm putting them out of order on purpose. And then I need to have a case where it's just a normal 8, 9, queen, jack, 10. Okay, so 8, 9, 10, jack, queen. Okay, so these are all different types of straights that we have, right? These all should come back as true if my logic is correct. And so feeding it this one here, I'm going through and I'm checking to see if I have any 10s. I do. So this should deal with the 10s if I need to. And then it's seeing if the set is, if it's not 5. If it's not 5, I return false. So if I have any kind of pair, I'm going to get a false in there. Then it's going to go into this else statement at that point. So if I do have 5 unique values, this king, the jack, the 9, the 10, or queen, then it's going to start this logic here. And I'm making a new list called converted values, and I'm converting my string values into these integers or a tuple. In this case, I should get a tuple. No, I should not get a tuple in this first case. And it's going to see if it's in there. If it's not, it's going to go through and then sort them and check to see if the values, the highest value minus the lowest value is 4. Because if you have a straight with these values, 5 cards, in any case, the last item on the list, subtract, and you subtract the first item on the list, you're always going to end with 4. All the way down to 2. So 2, 3, 4, 5, 6. 6 minus 2 is 4. 9, 10, jack, queen, king. 13 minus 9 is 4. So it should, that logic should work. And so that's kind of where I'm at with this one. So if I run this, okay, so I get a true here. I have a straight, a false here. So 9, jack, queen, king, ace. Yep, that's false. This is true. And then this is true. So if I change this here to a 10 and ran it again, they're all true. Those are all straights. Any questions on that? This is like mega function, right? So the biggest function you've seen so far in the course. There's a lot going on with a straight that you have to think of, all these different factors, right? We have to see if we have unique values, and then we have to see, we have to deal with the ace, which could be high or low. How do we deal with that? Well, this is how we deal with it right here. We first get the tuple, we remove the tuple, and see if the sum of the cards is 14 or 46. If that's the case, it's true. That dealt with both of the two different straights that we have. And then otherwise, we just check to see if the sorted list, if the last value minus the first value is 4. If that's the case, we have a true. And if you want, I can go ahead and print converted values here. So you can kind of see the results of that converting from a dictionary. These are the converted values from the dictionary. And then I can do converted values. Cool. And I can run that. And there's how you see it. Each one of these got converted from the corresponding list here. Any questions? I'm sure there's probably plenty. Okay, let's move on. Because we have not done pairs. We have not done 3 of a kind, 4 of a kind. I know we only have 15 minutes. Do y'all want to stop here and answer any of the questions on the program, or do you want to continue? Because I don't know if we can get through maybe a pair. We can probably get through a pair in the time we have. Continue? We can continue. Let me clear these outputs so I have a little cleaner code. So we can do is pair for our method here. And again, we're just going to get our cards. Okay. And if we think about a pair, how can we evaluate for just a pair? And I can give you a hint. It's kind of the same way that we evaluated for like unique values in a straight. So if if I were to use just like we did with the straight, right? I went ahead and made my values a set. And in this one, I check to see if the length of values, if it's not equal to 5. If it's not equal to 5, I'm returning a false because I need to have all unique values before I move on. So I check right here, is the length of my values, the set, is it less than 5? If it's less than 5, I have at least 2 cards that match, and then one of them is not being added to the set. And so my length is 4 or 3 or 2. So in any case where I have a 4 of a kind, 3 of a kind, 2 pair, full house, I have matching values, and they're not all being added to that set because sets only have unique values. I can use that logic to define whether I have a pair or if I have I think that's it, because the other ones have multiple results. Like if I have a full house or 2 pair, nope. If I have a full house or 4 of a kind, I'll have 2 unique values in a set. If I have a 3 of a kind, I'm going to have 3 unique values in the set. So this one should be pretty easy for a pair. I can say, okay, well, I have my values. So you can see the theme here. I'm kind of making the same variable names in these functions because the variables can be reassigned to the same names inside of functions because they have their own scope. So values equals set. And then I can say for card and cards, values dot add card. And then, oh, I need to do the same logic here, right? So because if I have a 10, I need to make sure I count for that. So I can just do that. I can just do that, right? Okay, so for card and cards, if Lynn card is 3, then add the card with the slice. Otherwise, add the first value. And then if Lynn values equals 4, result equals false, result equals true. Return result. Windows again. Okay. So again, to talk through this in my function, I'm feeding it cards. So in this case, I'm feeding it just the cards I'm already determining just to test my function. And I'm setting result to false. And then I'm making a new variable called values. I'm saying to an empty set. So I'm calling the set method to create an empty set. For every card in cards, I want to see if the length is 3. And that's the case right here. I have the 10. So if that's the case, I want to add values. I want to add the slice of that string, which is going to be the number 10. Otherwise, I just add the first value because in the other case, I'm only have one value there, and I'm going to add that. So now I'm going to say if the length of values, which is a set, if it's 4, then I know that I have a pair, just a single pair, not 2 pair, not 3 of a kind, not 4 of a kind, because only 2 of them in the list will match. And then one of them will not be included, and I'll be left with a length of 4 of values. And then I can return. So if I run this, I have a pair right here, pair of 8s. Here I have no pair, so nothing is the same, so the length is 5. And this, I have 2 pair. I have a pair of 8s and a pair of 9s. My result length would be 3, and that's not equal to 4, so result never gets triggered to be true with that one, so it's false. Any questions on that one?
Can you just repeat that last part one more time?
Yeah, sure. So in fact, I can illustrate it for you here. So print. This is the length of the values set. Len values. Okay. So what's happening here is the same was happened before. We made a set and we use the add method to add the card, just the value, just this 8 or the queen or the jack or the 10, right? And we had to have that special case for this. Is only happens if you have a 10 because the length of your card would be 3. This is the only time your length would be 3. So we're adding the 10. So we're adding all those to a set. And if you remember what we know about sets is that they will only have unique values. So if we're only adding this in this list of cards, if we're only adding this value for every single card, if you notice, we're adding 8 once to values and it gets added, and we're adding 8 again. But in the set, that other 8 will not show up because it only takes unique values. And then it adds the queen, then adds the jack, then adds a 10. The length ends up being 4. And so right here, this is the length of the value set. It's 4 because I had a single pair. Then that triggers the result to be changed to true, and the result of my function is true. With a 2 pair, or with a this is a straight here. So all of them are unique. I end up with 5. Well, that's not a pair. So my isPair function says, nope, that's not a pair. And then here I have 2 pair. I have a pair of 8s, one there, and then a pair of 9s. Well, the length of that value set's only going to be 3 then, because it takes an 8, it takes a 9, and it takes a 10. The others are omitted when it gets added to the set. The set here on line 3. I'm adding them right here on line 6 and 8. I'm adding to my value set. So I'm using the powers of a set, the properties of a set, which is only unique values, to determine whether I have a pair or 2 pair. Does that make sense?
Yes, I guess just because in the last one I see 2 8s and 2 9s. I just think there's 2 pairs. So
There is, but that's not a pair. That's a different poker hand. This is only checking for a pair. So if we remember from the poker hands right here, a 1 pair, that's the only thing I'm checking for. I'm not checking for 2 pair.
oh, okay. That I get it now.
Yeah. And so that, unfortunately, we're basically out of time, so I can't go further. But you can see how I can use that to my advantage. That I can put my card values into a set and just check the link to see if I have a pair. And a 2 pair, will have a. If you take a look at a 2 pair, the set would be a 3. In any other case, would you have a set length of 3? Well, 4 of a kind, you would have a set length of 2. A full house, you would have a set length of 2. 3 of a kind, you would have a set length of 3, because you would have 3 unique card, 3 of the same card, and then a unique 6 and an ace, so you'd have a length of 3. So you would have to do some further checking, but at least you can narrow it down. So you can use a set to narrow down your hand to a 2 pair or 3 of a kind, and then you can run another check to see if 3 of them are the same in your original. Like there's all sorts of ways you can use these Python methods to check to check how your hand is. It's not how you normally would check, like with your eyes. This is totally different using a Python script to do it. And so, yeah, unfortunately, we couldn't put it all together, right? So we have all these different functions, right? You know, you can actually turn this into like a driver script, probably right after you shuffle it. So we would have we would start shuffling the cards, get the cards, and then we would start running through. We would actually build a logic tree to check if the results of these functions are true and combine them. So we could start like, is it a straight? Okay, cool. Is it also a flush? Oh, well, then you have a straight flush. So on and so forth. So you could do it that way. And that's what we were doing. We were building on these, you have all these different functions, and then you would call them to determine what kind of hand you have. So if you have a straight and a flush, then you know you have a straight flush. If you have a straight but not a flush, then it's just a straight. If you have a flush without a straight, then you know you just have a flush. And then you can check for the royal flush. That's a special value one. So that one here is check to see if you have a flush, and then it checks for that one unique way you can have the highest straight. So, but yeah, so that's how we would build upon this script. Is we would just build these different functions checking for these hands, and then we would call them all to know which hand we have. And I can put a completed script for you in the chat room that will show, like, it will be like a script you can run, so you can feed it, have it trigger and build a hand, and then it will go through and tell you what hand you have at the end. I'll provide that for you, just so you have the complete code, and then you can tinker with it. So
how long will we have access to the QuickPass Summer channel?
I think you'll have it for a while. I own the channel, so I can keep it up as long as you need. So I mean, if you go right into the main cohort, you're not gonna have time for this channel. You'll ignore it. So because there's other channels you'll be paying attention to at that point. But yeah, so we'll have it open for a while. I just archived the last one. It's that was 4 months ago that we opened it. So there's hardly any, after this course, there's usually hardly any communication anyway, but I'll still put that code in there so you have it.
Thank you.
Yeah, I usually get added to cohort channels and stuff like that. So I can keep track, and you can always reach out to me. I look at Slack basically every day. So if you have any questions for me for anything, I'll be happy to answer them. But if you get into the main cohort, whichever one you're in, you're typically going to be talking to your instructor anyway. So they've changed the course so many times from whenever I went through. I would have to go back into the material and kind of study it again. They said I can teach it, but I haven't. I have time for this course, and that's about it. My primary job takes quite a bit. So I'm going to go ahead and stop the share and stop the recording.